Hello and welcome back to class. My name is Maths Teacher and this is Math Hub. In my last video, we talked about the area of a triangle. In the previous ones, we talked about what a triangle is and the different kind of triangles we have. Today, I'm going to be talking about another thing just in the line of triangles, and it's going to be called Pythagoras Theorem. Now, Pythagoras was a Greek mathematician that lived in 569 BC, and he formulated this theorem for us to be able to calculate the different sides of a triangle. Now, this theorem is in real life use, interior designers, in wars, in sports, and what have you. But then, let's dig into it. We'll be dealing with a right angle triangle first off. And obviously it has three distinct sides. The first part is called the hypotenuse, which is the longest part. The other part is called the opposite, which is more like the side opposite the reference angle. And then we have what is called the adjacent. Now, Pythagoras in his theorem said that the square of the hypotenuse is equal to the square of the opposite added to the square of the adjacent. The square of the hypotenuse is equal to the square of the opposite added to the square of the adjacent. Now let's dig into it and try to solve some examples. If we have our hypotenuse, or let me say our adjacent, to be 8 centimeters and our opposite to be 6 centimeters. Let's work out the hypotenuse. We know that the square of the hypotenuse is the same as the square of the opposite, which is 6 centimeters, and added to the square of the adjacent, which is 8 centimeters. So hypotenuse squared is 36, add 64. Now, 36 add 64 is 100. And we can easily ask ourselves, what number do I have to raise to the power of 2 to give me 100? Because we raised the hypotenuse to the power of 2 and it gave us 100. Quick maths, 10. We'll talk about that in a different topic. Hypotenuse would be the square root of 100, and that's 10 centimeters. Easy. We could also have situations where we don't exactly have to look for the hypotenuse, probably the adjacent. So let's assume our hypotenuse is given to be 15. Our opposite is given as 9. But we do not know adjacent is given as 9, but we do not know our opposite. We'll still refer to this formula and say that hypotenuse squared, in this case, is 15. Opposite is not known, and adjacent is 9 centimeters to the power of 2. So 15 squared is 225 equals opposite squared plus 81. Now, from simple linear equations, we can easily deduct that we have to bring like terms together. And that means we have 225. 81 is positive here. When it crosses over, it becomes negative, equals opposite. So 225 minus 81 is 144. And like I said earlier, what number do I have to raise to the power of 2 to give me 144? That's easy, 12. So in this question, my opposite is 12 centimeters. But before I go, there is something I need to mention. When you have three numbers such that the square of the biggest number is equal to a sum of the square of the two smaller numbers, when you have them that way, they are referred to as Pythagorean triplets or Pythagorean triples, depending on what you want to call them. Pythagorean triples. So, according to my examples, I had 10, 8, and 6 as a Pythagorean triplet. I've also had 15, 12, and 9. We have a whole lot of examples of Pythagorean triplets, and I would like you to put them in the comment section. Thank you for your time, and I would also appreciate it if you share my videos, comment on them, and refer them to your friends to see. You might be helping them without knowing. Thank you. I'll see you in the next video. Bye.